Team Harmonics. We developed an electronic melodica. You can go next. So just a quick overview of what we're actually going to be talking about. So this is the organization of how we're talking through the whole development and completion of the electronic melodica. Moving on to our problem statement, this is actually the defined problem of what we're trying to attack and how we're trying to solve it. So we were looking at a lack of production capability in the music industry, right? So music itself is very skill-based, not necessarily very digitally interactive yet. So our goal with this project is to move into more of a digital realm while still providing an analog instrument to play on. So again, just kind of introducing how we're attacking this problem. So a melodica is essentially, think more similar to a saxophone where you have to blow into it and then press keys to get sound out. Similar concept but with a breathing tube and a keyboard. So with that in mind, we decided to implement a block sensor, contact switches, LCDs, microcontroller. Essentially what we're trying to do is we're trying to take these analog inputs, digitalize them, and then provide immediate feedback to the artist to show exactly what they're inputting and then also provide that information to production software. And then this is just a quick overview of where we're trying to fit into the market. So the first entrance is essentially the closest thing we could find on the market to an electronic melodica. That first one is over $500, and it didn't provide any of the production capabilities that our melodica is able to achieve. On the other end, you have a $20 melodica, which is completely plastic, and it's a completely analog instrument, so it doesn't provide any of that production capability. And then ours slotted at the bottom fills that gap, so it's not necessarily $20, unfortunately. It's closer to just over $200 is what we spent prototyping. This is not necessarily a final production cost, but it does provide that production capabilities as well as providing immediate feedback to the user.
So going back to what was our objective that I originally set out to do was build an electronic version of melodica that enables individuals of varying skill and experience playing and try to replicate the functionality of a melodica to be used for post-production and be able to connect to a digital audio workstation so that a music producer or someone that's just learning how to play a basic instrument like melodica can mess around with it and make all sorts of sounds or whatever they want to make it sound like. Our other objectives, going back to our modules, first is develop a case for housing. If you came around and saw, we had it nice printed out. We had a box for all our components and the keys on top to press the switches below. Next one is we wanted to develop keys that communicate with the microcontroller. Those are the contact switches you saw us pressing. Then we are designing to develop outputs and inputs. So on our inputs are the volumetric flow pressure detector. So that measures the user's air input blowing into the sensor. And then the keystrokes via the contact switches. So the contact switches are feeding the press, and then that specific node is being sent to the microcontroller. The other outputs are the MIDI interface, so that we use MIDI communication for connecting to the DAW on the personal computer, and then the speakers coming out from the computer to actually play the sound. Some other objectives are the microcontroller. The microcontroller is the heart of this entire project. So for the inputs, the analog inputs from the contact switches, the corresponding keys, and then we have the outputs, the analog and digital output signals for audio and MIDI communication respectively. And then finally, to make this whole thing work, we need to make sure to implement a functional MIDI interface. So we need to make sure that we had a communication protocol that allows use for MIDI communication.
So here you can see how the inputs will be used. So you have the volumetric flow, the key press being sent into the Arduino Uno we use Due. Sorry, Due. From the Arduino Due, it gets processed using a MIDI header file that we have on it, and then it's sent through USB and sent to the personal computer to be read by FL Studios, and from there it produces an audio of the key being pressed.
So the main software for we're using for electronic melodica. So we're taking the Arduino, we're taking the inputs, one from both the contact switch and the volumetric flow. So what we're doing is we're taking the contact switch and we're relating it to a specific note, whatever we decided it to be. We decided to center around C3. For music terms, that's 3 above center, so 3 octaves above center. And that just relates to what the actual sound was like when the keyboard was an actual melodica, when it actually sounded like before we took it apart. We wanted to try to mimic that sound as close as possible. So we created arrays and made sure to translate those keys to those specific notes. We then take those notes and the volumetric flow, and then we send MIDI communication from the Arduino to the PC. From the PC, there's 2 main applications that are being used. Loop MIDI, just try to think of it as a bit of a virtual cable, if you want, and that basically just connects the Arduino Due to the post-processing software, the digital audio workstation. And then it goes to the FL Studio, which is a digital audio workstation. From there, everything's being read, and the notes are being played, and you can make it sound like whatever you want to sound like.
So our objective status to date, we developed keys that communicate with the microcontroller, so those are the contact switches that we're pressing down. And then we have all of our inputs and outputs, so we have our volumetric flow, which is breathing into the tube, and then our keystrokes, which is actually physically pressing the buttons. And then, as we were saying, the outputs is you hear the sound, and then on the LCD, you see the note that's being pressed as well as a volume reading below it so that you can get like a gauge. So it's centered at 21, that's the basic value, and it goes all the way up to 200. So you can, nobody really knows how hard they're blowing, but you can at least see a digital value to see where you're at on the spectrum. So more of our objective statuses is so we wrote our code for the melodica, and so you can basically use that with any MIDI software communication. So that's just any Arduino to the microcontroller, and we just have our keys that are physically pressed for the melodica specifically. And then we have our communication protocol, which is implemented between the microcontroller and the MIDI, so that it's just constantly communicating and updating.
Alright, so just looking at both semesters in review. So this is the timeline throughout both semesters. We started with the actual formulation, focusing more on that right side. That is the past semester. That is when the project really came into fruition. That's when we actually got to start working with hardware, started to integrate stuff together, actually making the pieces, parts actually all work as a whole unit and actually make sound as an instrument does. So especially looking at, towards March, that's when we actually started integrating, and that's when we got to have, the amount of breath you're blowing into the instrument work in harmony with the keys that you're pressing, ultimately actually allowing for music to be created. So looking at our budget, overall, we didn't come too terribly close to our $1,000 budget. This is our allocation of parts on the left side. So from there you can see it wasn't necessarily what we expected. It definitely cost a little bit more, but throughout development and unintentionally blowing up a couple pieces, we did find that the components that we did vet and select actually came together very nicely. And then on the right side you can see the work hours that we came together. That's more just as a formality for the project, but looking as if this were an actual project, that's how it would have developed throughout both semesters.
So for our deliverables, like we said before, we want to deliver an electronic melodica that takes the user inputs, digitizes that information through a microcontroller into a MIDI interface, and allows the user to visually interpret what notes are being played through the DAW or on the LCD, which both displays the notes, and the audio signals that are being produced from the digital audio workstation. So our impact, we want to develop an existing instrument to more readily applicable in both professional and amateur music industry. This is by including a MIDI interface, microcontroller, and multiple options for output. The electronic melodica is providing a foundation to expand the digitization to other instruments to meet the modern industry music standard, which everything's going digital these days. So we wanted to take this analog instrument and provide it a digital solution. For our future work, everything is fully integrated at the component level. The next step is being cleanliness and user friendliness of the prototype. This means that progressing forward will be continual revision of the individual components and just making sure we put it in the box. And once we get everything in there and everything's set, we won't be touching it anymore. And then the keystrokes are being read, and then everything's good to go. Have any questions?
Is there a way that you could make it so that this would operate without having to have a PC next to it?
So that kind of goes away from the goal of it. So the entire goal of it is to be able to interface for post-processing software, as that's what the music industry has moved towards. Everything is done through digital audio workstations and post-production. So the whole point of it is to be connected to a computer so it can be read for post-production. If we want to do it without a computer, we'd have to change pretty much the entire project and get away from MIDI, and then we'd have to move to a sort of on-house audio production, which was one of our original plans, was to produce the audio in-house. That kind of goes away from the original goal of getting it integrated with the current music industry, which is making sure everything is able to connect to that digital audio workstation, so all the post-processing can be done at one place and everything can be integrated together, so it can be played with other instruments and you can make it sound like whatever you want.
Would it be possible to have a wireless communication to the digital? I'm envisioning a melodica used in a concert setting, because melodica concerts.
Yes, so we did look into a couple of that. All that would take would be a Bluetooth USB communication. You connect that to it, connect to the computer, we're just the same.
Can you hit multiple notes at the same time to make a chord?
Yes, you can play, you can smash your arm on it and play all 37 keys if you really wanted to.
Can you talk about what was the most challenging part of do this?
Yeah, so for me, I think the most challenging part was integration. So I got my part working. I went through several different parts that sort of worked, but not really, because most of the time, if you're trying to detect like velocity airflow, it's for like an industrial application, so like very, very minute changes. So you found we were oversaturating the sensor. Mr. Knapp actually did some research for us and recommended the current one we're using, the SparkFun air velocity sensor, and that already works with Arduino, so that was very nice. Shout out to Mr. Knapp for that. But then like integrating that with the rest of the project was, we could get like one part working at a time, and then we couldn't figure out why it wouldn't all work like seamlessly. So that was a lot of hours trying to debug it and going through various solutions, trying to troubleshoot what exactly was going wrong.
So I'll agree with Robert on the fact that integration was, in fact, a difficulty when it came to the project. So getting each individual component to function on its own was not as difficult as it could have been. We actually had great success in making each component function as we wanted to, but when it came to integration, there's definitely conflicts between both the hardware and the software that made it more difficult. I'll also like to state that developing the project without hardware, so earlier in that first semester was definitely a difficulty, just because, I mean, we're excited college kids, we want to get our hands dirty, we want to start putting stuff together. So actually sitting down trying to formulate how to develop this project, how to make sure that every component is interoperable, and then going from there and actually trying to start to develop, you know, hardware schematics, initial software, just so we have a launching point. That was definitely another difficulty that made us sit down and think a little bit.
Just like the other two, the most difficult part for this project was the integration of everything together. I worked mainly on the programming, so trying to get the SparkFun airflow sensor and also the LCD to work together using I2C communication. It was difficult at first, and then with the recommendation of Mr. Knapp again, we looked at the wire.h library that the Arduino has available. Funny enough, both of the, so we use a library for the LCD and then we use a library for the SparkFun. With the Sparkman, it doesn't, inside of the library, it doesn't have a wire.h initializer. So you have to initialize that within the program that you create yourself. But with the LCD, inside of the library, it has a wire.h initializer. So for around, what, 2 weeks? Almost 2 weeks trying to figure out why these two components aren't communicating correctly. I opened up the LCD header file and found that I needed to change the way it initializes itself. And the next second it worked, and so that's just.
Yeah, there was a big challenge initially. I have a bit of a music background, but trying to understand how the ancient technology of MIDI actually works and like what does it actually do, like how's it actually communicated, was definitely a big difficulty, a big learning gap to try to figure out how the whole thing actually works and how stuff actually communicates, especially in a modern digital age where it gets super complicated when you have a lot of things connected together. Another big thing was delay of parts. We still never got one big part that would have made our project a lot easier. So we had to kind of make do. And soldering that board together took a long time. And we were in there for quite a bit trying to get that board soldered together. And the precision of trying to put those switches under the keys, it's extremely precise. And just trying to get it in there has just been a really big challenge. It's one of our future goals as well, to try to get this thing under the switches as precise as possible to get all the keys being read. But definitely the lack of the part being ordered or the part coming and trying to figure out what the heck a MIDI is was definitely the biggest challenge.